So next we'll move on to Taylor Adams, the next speaker.
Awesome. Thanks for coming, everybody. And I'll probably be saying next a lot because I have quite a few animations. Next. So to start, why do we care about nitrogen dioxide? Well, a few of these reasons are the following. It's a precursor to ozone and smog. It's a respiratory irritant by itself, and it increases greenhouse gas lifetimes. Next. So an issue with the current monitoring of NO2 can be seen in the figure on the top left. Here you see long-term NO2 monitoring sites across the US, and you can see that in this figure, there's a lot of major cities and entire states that lack long-term monitoring. And below, you can see that in 2019, the average NO2 observation from Tropomi, which is an air quality observing satellite, reveals that satellites provide complete coverage over the US. But there is a problem with this. If you could click. So if you zoom in over the Boston area and you look at the spatial size of satellite observations relative to our 3 surface sites, which from top to bottom are Harvard, BU, and a site in Milton, Massachusetts, you can see that satellite observations are spatially coarse, and on top of this, surface observations are needed to validate satellite observations. Next. So, So this is our current air quality monitoring network, just to give you a layout of it. We've got sites at Harvard, Boston University, and Blue Hill Observatory, if you could click. And these are the instruments we have stationed there. So these are called Pandora spectrometers. But what do they do? If you could click. So this is what they do. As you know, sunlight comes down from the sun to the surface of the earth. Our Pandora instruments, they intercept the sunlight, and they're able to use those observations to tell us the abundance of trace gases in the atmosphere. Satellites do something fairly similar to this, where the sunlight, it comes down, it touches the earth, and it backscatters up. And satellites observe backscattered sunlight. So we're able to draw comparisons between these 2 instruments. Next. So in this slide, I'm going to give you a feel for some of the issues we want to tackle with our air quality network. And as a reference above, you can see a diagram of our network again lined up with the satellite observations below. So we're lucky in our network that we have 2 sites, Harvard and Boston University, that are very close together, about 1.9 miles apart. And because of this, we have 2 instances. We have instances such as on the left where they're in different satellite pixels, but also some such as on the right where they're in the same. In the left example, Harvard and Boston University are in the same, are in different satellite pixels, and these satellite pixels have a difference between each other of 28%, but the Pandora observations are only 7% difference. On the right, the satellite, they're both in the same satellite pixel, and so the satellite observation for these 2 sites is the same, but the Pandora showed a difference of 11%. We hope to use instances like this to better understand what drives agreement between satellite and surface observations. Next. So to close, with our network, we hope to answer a lot of questions regarding NO2 in urban settings, such as what is the scale of NO2 variability, to what extent does within satellite pixel variability exist, and we want to better understand how satellite observations relate to surface pollutant concentrations. That's all I have for you today. Thank you.